Pulsars are a kind of star that blink like a lighthouse spinning. Every time the pole comes towards Earth, we see the hotter part of the star as a blink of radio and X-ray light. And it turns out these stars are really stable. They're as reliable as basically anything that we can measure in the natural world. So we can predict when we should see blinks from these stars and use that as a reference for timing and navigation around the solar system. Pulsars were discovered in radio wavelengths, but radio telescopes are huge, like more than 100 feet across. So we're working on X-ray wavelengths instead. X-ray wavelengths are really small, like nanometer scale. That helps make a smaller instrument. So we're working on building smaller telescopes to observe pulsars that could then be used for navigation. So I've been looking at recordings from the last 7 years of the brightest pulsars to see what they look like and what colors are brightest. I'm also working on actually making mirrors. So we have equipment here to take glass and melt it into the shapes we want and then coat them with thin films so they're reflective to X-ray light. And we work with a team at the NASA Marshall Space Flight Center in Alabama. And then the last step would be prototyping an actual instrument. I received the NASA Finest Fellowship. So that's a 3-year grant that allows me to focus on research full-time. And then I also received the Iowa Space Grant Consortium's Award, which is additional support from the state to be able to focus on this work. The Deep Space Network is supporting quite a few spacecraft already. And so if we want to build more spacecraft, launch bigger networks of vehicles to go explore the moon in more detail, build lunar networks for supporting Artemis, or send spacecraft to Europa. If we find something really cool with the Europa Clipper mission, well, a pulsar navigation system would allow them to each do that on their own autonomously without relying on an Earth-based center point.